Hi everyone, thank you for inside of my talk about the managed secrets across cloud on Kubernetes. That's me, that is Jhonnatan Gil, DevOps engineer at AppGate. I start the talk about the one phrase, life is real simple, but we insist on making it complicated by confusion. I love that phrase because when you try to do something new for your team or generate new value for your company, it's very hard when you implement this with a new technology, or in this case with Kubernetes, when you try to do something different where your knowledge, it's very hard to generate new tool or generate a specific tool for with best practice or with secure. It's very hard. It's a learning path, very difficult. But when you learn this new, you can generate new feature, you generate more value for your company. But every day that you learn something new, it's very hard because implement this in your company, in your job, in your ecosystem, it's very hard for you and your team. In this case, we learn about how to use secrets over Kubernetes, how you can use these secrets for your cloud environments or on-prem environments too. In this case, bare metal for Kubernetes is more fashion, could be, and learning how you can use these secrets for your Kubernetes cluster, and how you can get from your cloud provider, and how you can obtain these new secrets for your cloud environment, and how you can get these secrets for your cluster ecosystem Kubernetes. That's it. Learning something new. Okay. In this talk, we're talking about the AWS SSAM, Azure Key Vault, GCP Secret Manager, HashiCorp Vault, Kubernetes, a little spec about Kubernetes, and the object inside the Kubernetes that is called secrets, how you can use external secret that operator inside of Kubernetes, and how to install could be a little steps for use that, and a little demo about the how to use secrets in Kubernetes using Vault, and how to mix this ecosystem, and how you can use every day on your Kubernetes cluster. Talking about the AWS System Manager Parameter Store. Parameter Store is a capability of AWS System Manager provides secure hierarchical storage for configuration, data management, and secrets management. You can store data such as password, database strings, Amazon image, IDs, and license code as parameter values. Your secrets are around the AWS, and you store this in text plain, in this case, or row, and you can encrypt this data with your HSM managed key generated inside the AWS. You can use that for your deployments or your ecosystem or your EC2 instance or your virtual machine inside AWS, right? In this case, we're talking show how do you create parameter inside the AWS. You create parameter inside like a standard that is generate my pool, that is the path like that I use. In this case, my secret is called my secret AWS. In this case, the pool for that is my value, right? You can use this secret, in this case is plain text, for obtain from my deployments or obtain from my applications around my ecosystem inside the Kubernetes or outside of Kubernetes. Could be like a function as a service in AWS is called Lambda. You can use that from inside of Lambda and obtain this information around the database strings, or could be endpoint from other API that I can use. You can store this secret secure way, and you can obtain this secret from secure way. In AWS, you can define in AMI account with from associate from a user or from a role from a different ecosystem that you can deploy in there. You can define that role uses from Lambda or use from EC2 instance or use for virtual machine and obtain a specific this secret and just can use for read, don't for write, just for read, and can update in this case. For the ecosystem, the secure team could be updated this secret for obtain and generate new value for your tools, and how you can generate this perspective for your team, for all your teams and all your company, and how you can define this process when the applications can obtain only this the secure secret, and how the secure team can update this data without the developer team could be check this data or IT team, just the secure team. So that is a big feature for the cloud, and how you can use that in all Azure Key Vault secrets. Azure Key Vault is a cloud service for security strongly and accessing secrets. A secret is anything that you can want to tightly control access to, such as API keys, passwords, certificates, or cryptographic keys. Key value service support two types of container vaults and manage hardware security mode. Each is SAM pools. Vault support storing software and each is backend. Keys, secrets, and certificate manage each is SAM pool only support HSAM backend keys. That's very could be confused for learning in this path, but in other words could be how you can store your data in secure way, right? In this picture, check how can you create a new secret over the Azure, and how you can store the secret like AWS, and how to this similar for AWS, and how you can use in Azure, right? You generate a vault primary in Azure, and secondly you can generate a secret over the vault. And what is the type of the secret you can generate inside, and how you can put this secret over the Azure. Azure manage airbag access control for the all ecosystem in your cloud, and how you can put all together, how you can use this like a function as a service over the Azure. Now how you can obtain this secret from Azure as a function fast, or like virtual machines, or from your database, or from your ecosystem around your deployment inside the cloud, and how you can obtain and how you can put there all together inside the Azure. In this way you can generate granularity for your teams, or for your developer teams, or IT teams, or security team, for obtain this granularity option from how you can use for your proposal, or how you can change all your ecosystem around the company, and how you can obtain this feature and generate this process for your company that it's in very high level, because you can generate could be the security team update the secret, and how the developer team could be obtained. No, the developer team can obtain this secret just the application when this application is deployment. In this way you can generate this process, and how to and who can update this secret and how to obtain from application and how to use that for all ecosystem that you generate inside around the ecosystem, the application, right? Okay, checking other clouds, GCP Secret Manager. Secret Manager is a secure and convenient storage system for API keys, password certificates, and other sensitive data. Secret Manager provides central place and single source truth, manage access and audit secrets across Google Cloud. That is definition is taken about this gets from GCP around the how to store and how to manage secret or inside that, right? In this case, we have this picture about how you can create over the Google Cloud the secret. You generate a secret like AWS and Azure, generate a path could be, or generate just the name for your secret, and what is the value for your secret, right? In this case, in GCP, you can generate the granularity for your teams and the application, and how you can use this definition around your process, how you can put together for the application, and how your security team can be updated, and how your application can get this updated from your secrets for the security team, and you can change that for your granular definition in there. Your matrix could be, or your role associated inside for your company, and how to the secure team just can change and just generate and just update this secret, and how to the application obtain this secret updated from your GCP Secret Manager, and how to this application, only the application can obtain this secret, not the IT team or developer team, like as well in Azure and AWS. HashiCorp Vault. Vault is a tool for secure access in secret. A secret is anything that you want to tightly control access to. So it's an API key, password, certificate, will provide a unified interface to any secret while provide tight access control and recording and detailing audited log. Secured secret storage, arbitrary key value secret can be stored in Vault. Vault encrypts these secrets prior reading them to persist the storage or gaining access to the raw storage. Using no access to your secrets, Vault can write disk, console, and more. Right? In this case, HashiCorp Vault could be a interface for all your secrets around your cloud provider or on-premise infrastructures too, and how you can manage this secret out of the box from the cloud providers, and you can generate this interface, and how you can generate this process. You can define in Vault to granularity definition, your matrix for your teams, and how to the security team generate and update these secrets, and how to about the your modify, and how you can obtain this secret only for your application, how you can put all together. That works very nice for your teams and your paths for your successful security in your company, right? In this case, the pictures show how you can create a key vault secret is in Vault. First, you create a vault. Second, you create a secret. And third, you can create your secret over the cloud, over Vault, for present this secret for your workload or for your function as a service out of the box for the cloud provider or on-prem. Could be you can install this solution on your machines, on your ecosystem, on your virtualization could be, or the HashiCorp could be generate this new tool for all deployment that you put all together. In this case, you can deploy these to in the Kubernetes cluster could be generate a security cluster only for the storage. All your vault secrets and how to your security team are managed for this cluster only for the company, right? You can put all together and generate separately for developer environment or staging environment or production environment, and how do you can separate these responsibilities for all environments, and how to the security team can generate this new feature for the whole company, because you can generate a new process, and how do you can storage, and how do you manage all secrets for the company, and how to can you provide these secrets, and how to you can get these secrets for all application around there, or your cloud providers or your deployments that you generate inside the clouds or generate out of the clouds. Okay, talking about Kubernetes, it's an interesting technology. Could be increase a lot of the expectation in all around the world, and how you can use that in all specification in your company, and how to this very disrupt for your company and for your teams, and how you can increase all values for your company. That's a good technology that you can use in your ecosystem for your application or for your IT environments. How you can use that with virtualization for increase the value for all teams and your application. That's very good. Talking let me as a little definition about Kubernetes. Kubernetes is a portable, extensible open source platform for managing containerized workloads and services that facilitates both declarative configuration and automation. It has a large, rapidly growing ecosystem. Kubernetes service support and tools are widely available. Yeah, it's a very explosion for your Micro app could be, but and how to you can use Kubernetes and how to increase your value for your company with that. That it's a good question for you or for your company. How do you can use Kubernetes for all your ecosystem, all your apps, all your teams for generate new value for your company. Let me check about the little object inside the Kubernetes. Is a secret. Secret is an object that contains a small amount of sensitive data, such as password, a token, or a key, such information made other side, but put in a pod specification or in a container image. Using a secret means that you don't need to include confidential data in your application code. That it's a very nice definition, because you can extract the sensitive data for your application, for your code, for your repositories, and how you can put this data inside your application around your Kubernetes ecosystem. That it's very nice. In this part of the picture, talking about the master node, how to work Kubernetes. Kubernetes works with one master node and one worker node could be, but it depends for your architecture, depends for your availability zone, depends for your replication for your application, and how you can put your infrastructure, your application, your business for all your clients, and how to these clients your application for all your needs, right? In this case, it's a single ecosystem for Kubernetes. It's a master node and worker node, and the worker node deploy a pod, a workload, a container that you can define your application. In this pod, you can inject the secret for your ecosystem, right? That is could be the small definition with Kubernetes and secret, but you can use more around that, because you can put in your pod, in your containerized application, your secret into in three ways, sorry. This way is environment variable, or a file, or a path with a lot of files, but depends for your architecture, for your application, and how to the application gets this configuration or these passwords or these sensitive data for use in that, right? Depends a lot of your application and how to the developer team could be obtain this data for your for generate the value for the application. Talking about the external secrets. External secrets operator, it's an operator that integrate a secret manager system like AWS Secret Manager, HashiCorp Vault, Google Secret Manager, Azure Key Vault, and a lot of other cloud providers. How to you can get this information, how to you can get this sensitive data for your cluster, right? These APIs connect with the operator and update this data for your bot, right? But what is an operator? What is Kubernetes? What is operator? By that new term, operator are the software extension for Kubernetes that make use of custom resources to manage application and their components. Operators follow Kubernetes principles, notably the control loop. In this case, when you work with operator in Kubernetes generate new things for your teams, and how you can increase the value for Kubernetes could be just for you, and you can use operator for increase this value for Kubernetes, and how you can use for your company new features that could be not generate inside of Kubernetes is just for you and your IT team, and how you can generate this toil task, and you can manage this task with one operator developed by you or your team, and how to reduce the time that you can use for generate some task, and you can define this task over the operator, right? You can change everything in Kubernetes, and how to the Kubernetes how to the operator could be generate for these new responsibilities with an operator, and how to you can deploy more easily, more fast, and that it's a very extensible. You can use this operator for your teams and your clusters, and how to develop that in your company. That's very nice that work with Kubernetes. Let me show you a little architecture high level that Kubernetes and external secrets use. First, you define a secret in your providers or bare metal. In this case, with Azure, with GCP, with AWS, or Vault. That is the last slides. You can use any ecosystem that you define for your application, or your security team could be defined for your company, that covers all needs for your company, right? Second, you can write this definition for your file, for your YAML file, that is the description of how you can obtain this data from the external provider, and how to obtain these values for the bot, for your workload, for your application, and how to obtain and how to put in there, how to the application wait this secret, like a environment variable, or file, or a path for a folder, could be, depends everything about the how to the application is created for the team, for the developer team or architecture team, and how to define how can get this information for the bot or the application, right? And third, you can use this secret in your cluster, in this case, or just only for your bot. Comes to the demo, right? Okay, in this demo we show how you can use external secrets in your cluster environment, and how you can update and install first the Helm chart and how you can use this chart and configure the chart for connect for a bolt in this case. First, you need to add the external secrets Helm to your installation in the cluster. In this case is this command. We add the Helm repo that name external secrets that it's linked for this Helm chart in internet location. In this case, we can check what other repos can install in our cluster. In this case, repo list. Now we can check external secrets. It's added for the moment for our external secret for our cluster and how to can use for that. This enable the Helm, the chart, and you can use this chart for the configuration. Second, you need to install external secrets into Kubernetes. External secrets with Helm, enable external secrets that invoke external secrets chart that install and obtain external secrets value for this case. In this case, we can check generate the external secrets namespace, but in this moment, if we can check the currently namespace is created, actually we have this namespace in our cluster. kubectl get namespaces. In this case, we can create the external secrets namespace and don't create this namespace. Can copy for that command and pass in theirs, and you can execute this command. In this case, Helm generates all values for your cluster and the operator can be enabled for the cluster. In this case, we can execute part of the operator and configure this operator if you need it. But in this case, we can check how to can use this operator. Helm list. In this case, external secrets, it's enabled for our cluster in the namespace. External secrets is the first revision is deployed in this case. In this case, it's a lot of objects generated for external secret. kubectl get pods. It's a new pod for this case. In this case, the external secrets, and if check the API for Kubernetes, kubectl app resources grep. In this case, use external secrets. Oh, sorry for that. External secrets. In this case, generate external secrets. That's a new extensible for my operator and how you can use. In this case, external secrets, or this is the qualification for minus if you can use kubectl get external secrets or kubectl get AES. It's the same way that you can find all objects in the namespace for the external secrets. In this case, don't show any resources because you need first configure the resource and second use the resource for the generate new obtain the information about the bolt, right? In this case, we preparate secret inside bolt. This secret is called my secret and obtained from bolt, right? First, generate the secret bowl. We generate, in this case, just installation about external secrets. Now we can configure secret store from one secret bowl YAML. Check what information have this YAML. This information is first, create a secret that it's named bowl token. This token is the communication from the username, in this case for the root name, that can you obtain this authentication for the vault in this server. And this part is just the token for vault, but in this case, in this part is the configuration about the server, about the what is the path of the vault that you can connect. In this case, that is the API version. How you can call this secret store, in this case is vault's backend, and how to authenticate for the vault. In this case, use the token authenticate and use the vault token that generate in this secret. In this path, the secret obtained when the configuration it happens. It's the first part when you can check the operation teams could be don't know what is the secret. In this case, I can separate the files, and this file is the security team, and this file is the operation teams that can generate the configuration around the what is the vault service or vault server that I can use. And this configuration, it's the common for the security team and operation teams or IT team, that you can use what is the name of the vault that you can generate security team, and how to the security team and IT team define this name for generate and establish some definitions, how the names about the secrets around the Kubernetes could be put in there, right? Next step, just apply this file, but after that we can check that what type of secrets exist in there. kubectl get secrets. In this case exists this secret, external secrets token, external secrets token, secret store, that secret, but not it for that. And this is the installation about the helm that we generate in the last step. All right, and this is in secret store. kubectl get secret store, that another configuration about the secret store around the external secrets, right? That's it. Then apply this configuration file, and in this case generate a secret and secret store in the namespace that we in there, and check what object generated. In this case kubectl get secrets, and voila, that's my secret that I generate, that it's vault token, that is the name of the token that we send in this case with this value. And we can check exactly with secret store that this vault backend that contains all configuration around the external secret and how to connect with the vault and my secret for generate this authentication for the application, right? In this guide, config external secret from vault. Using external secret is definition on how to you can use external secret and how to this before this authentication, you can use external secret for obtain the secret from vault. In this path, we can check my secret vault, this property for secret, the secret generate for my store configuration, in this case is example sync, and generate a secret store reference for my secret, that is the backend, the vault, and it's a secret store, right? In this case, secret store is vault backend, this configuration that we generate in this case. In this definition of how to authenticate, before that it's authentication, you can use this authentication for obtain this secret, right? Before the authentication, you can obtain the secret in this path, exactly this secret, and put in my new secret definition, example sync, and put in their foobar, right? Let me check more simply with the example. Apply this configuration file. In this case, generate bold example, that it's our external secret generation, kubectl get secrets, and voila, this is example sync that contains the foobar definition. kubectl describe secret example sync, and this my foobar, my information about the secret. In any case, I can use this secret that I obtained from Vault, from my pod, and inject this secret in input of my pod with environment variable, or can use for config file or a path if I need it. Depends exactly what is the architecture for the application and how to can use this secret for the application and how to can inject in there. For the talk, we're talking about how to you can use the secret generated by external secret and how to implement, in this case, for a deployment over the pod. In this definition, we have a deployment from, in this case, this example that use image in based in Nginx. This expose port 80 and use, in this case, that is the important part, the secret username, right? That secret username is valid from secret key ref. In this case, you invoke the example sync and obtain the foobar value. That's the definition that we generate in the previous example that define the example sync and generate the foobar that obtained from the vault in this case, right? Just apply with this command kubectl apply F3, and in this case generate a deployment kubectl get pods, and voila, this is a example deployment, right? kubectl describe pod, this pod exactly, the example deployment, and in this case we can check something new. In the deployment, put in there the pod, the secret environment, secret username, connect the secret example sync, and obtain foobar. In this case, if we can check the secrets in this deployment, in this namespace kubectl get secrets, we have example sync that contains, is in this case get secrets describe secret that obtain the foobar data. That is the complete flow that you can use define for first the security team how to define the connectivity and authorization and authentication over the vault, and how to in vault you can define this secret that don't know the developer team or IT team, just for the configuration, in this case for IT team, this other for configuration that could be generated for the IT team, they using secret, and third, the development team just use the secret for the environment and put in environment for the application. The all process around the how do you can define how do you can sensitive data could be secure in your whole ecosystem in the CLDC lifecycle could be generate new value for the company, because the secret that could be injected for the database, or could be something other service, or this very sensitive data, the IT team or development team can't access for that, just for the application and the security team, and it's the more powerful tool that you can use for the connect your cloud, and you can connect the bare metal too for the external secret, and how do you can use this external secret for the Kubernetes, and how to these external secrets generate a new proposal for all your company, and how do you can determine this for your company new process that the IT team and development team don't know what is the sensitive data, just the secure team and the application, no more. In this case, it's a good example for the application. The slides contains the video about the how you can check this offline could be, but you can explain in this video what is the part of the secret and what is the part of the HTML files using for demo. You can check this video too if you want, no problem. If you have some questions, you can send me a ping over the social networks like Twitter or YouTube or GitHub. I hope that you can learn something new. Thank you for your time. See you soon.